Welcome back. So in this video, we're going to talk about solving special right triangles. So I already took the liberty of doing your 30, 60, 90 and 45, 45, 90 triangle ratios up here. This should be a complete review and a recap from your geometry days. So with AP Pre-Cal, we're going to kind of take things a step further, but we are going to be using special right triangles a lot. But rather than learning about special rights, we're going to be learning how to apply special rights. So with the special rights that we're going to be doing, we're just going to do kind of a quick recap. This should serve as a review. So we're just going to kind of dive right in. So in order to do the special rights, I use a concept that I call DIMO. So it just means divide in and multiply out. So using your ratios for your 30, 60, 90 across from your 30 degrees is going to be a ratio of just 1. Across from 60 degrees is going to be a ratio of root 3. And then across from your 90 degrees is going to be a ratio of 2. So that's kind of how I have it written out down here. And then for your 45, 45, 90, just note that they're always isosceles, which means the two side lengths are going to be congruent. So across from both of your 45 angles, or degree angles, it's going to be ratios of 1, whereas your ratio across from 90 is going to be a ratio of root 2. So with your 45, 40, or with your special rights rather, I'm going to use DIMO. So looking at 22 here, so this is kind of a continuation of the trig stuff that we just did previously. So with DIMO, I know that based on this triangle, if we have a 60-degree angle here, and then we have our 90-degree angle here, that means that this angle here has to be 30 degrees. And then what I'm going to do is I'm going to write in my ratios. So across from 30 is going to be a ratio of 1. Across from 60 is going to be a ratio of root 3. And then across from 90 is going to be a ratio of 2. So what I'm going to do is I'm going to take the given value and I'm going to push this value inside the triangle. And when I say push in, I mean I'm going to divide going in. So when I say divide going in, I'm going to take the value and divide it by its corresponding ratio value. So here I'm going to do 4 divided by 1, which is going to give me 4. And then that was the divide in. Now I want to multiply out. So I'm going to push this value outside of the triangle on both sides, and I'm going to multiply the interior value by the corresponding ratio value. So for the other leg length, I'm going to do 4 times root 3, which is going to give me 4 root 3. And then for the hypotenuse, I'm going to do 4 times 2, which is going to give me 8. So your missing values that we're going to have are going to be 4 root 3 and 8. So this is what I mean by solve, is you're going to be finding all the missing values. So it's 23. Now notice how we have 2 side lengths of 6, which means this is going to be a 45, 45, 90. So 45, 45, 90, these are going to have ratios of 1, 1, and then root 2. So when I do DIMO, I'm going to divide going in. So it doesn't matter which leg length you choose. I'm going to do 6 on the top. So 6 divided by 1, which gives you 6. And then we're going to push it out. We're going to multiply out. So your hypotenuse would be 6 root 2. Okay, then moving on. So we have another 45, 45, 90. So 45 over here. We have 90. Your two leg values are going to have ratios of 1. Your hypotenuse will have a ratio of root 2. So I'm going to divide going in. So 9 root 2 divided by root 2 is just going to give you 9. And then when you multiply out on both sides, we're going to have leg lengths of 9. So these are kind of your rudimentary, kind of mundane, basic ones. So we're going to try to step it up as we go throughout some of these problems. So looking at 25, your next one. So given 30 degrees up here at the top, and we have 90 at the bottom right, that means this is going to be 60 degrees over here in the bottom left. So your ratios across from 30 is going to be 1, across from 60 it's going to be root 3, and then across from 90 is going to be 2. So once again, divide going in. So 10 divided by 2 is going to give you 5. And then I'm going to multiply going out. So when I push out going down, 5 times 1, which is going to give you 5. And then 5 times root 3 when I push out to the right, it's going to give you 5 root 3. So next, we have another 45, 45, 90. So your ratio values are going to be 1, 1, and then root 2. So when I divide going in, I'm going to do 18 divided by root 2. So this is where it's going to get, or begin to get a little tricky, because now we're going to have to rationalize. So I'm going to multiply by root 2 over root 2. So that's going to be 18 root 2 over 2, which is going to give you a value of 9 root 2. So 9 root 2 is going to be my interior number. And then you're going to multiply going out, which means we're going to have leg lengths of 9 root 2 and 9 root 2. So same idea. So with 27, now we have 30, 60, 90. So across, we're going to have 1, 2, and then root 3. Okay, so now I'm going to divide going in. So 15 divided by root 3. And of course, we're going to have to rationalize. So that's going to give me 15 root 3. That's a 3. Then divided by 3. And then simplify. I can't draw a 3. Still can't draw a 3. There we go. And that's going to give me 5 root 3. Okay, now I'm ready to multiply out. So I'm going to push out on the left side, which is going to give me 5 root 3. And then on the hypotenuse side of things, now we're going to multiply by 2. So 5 root 3 times 2 is going to give me 10 root 3. So it's the same idea for the last three. I'm going to skip over those. We're going to go into these composite figure shapes. So these are the ones that I personally like the most, just because it's a little bit more of a challenge. So given this composite figure here, so we're given that x is equal to 12, and we want to find the value of y. So in this case, what I hope that you notice is we have isosceles triangles on the, or an isosceles triangle over here on the right side, which has a hypotenuse value of y, since it's across from the 90-degree angle. If we have a 45-degree angle, not 45, 90-degree angle over here that is split, and then we have our hypotenuse, that tells you this is kind of like the corner of a square or rectangle, which means when I bisect it, this is going to be a 45-degree triangle. So that's going to give you 45, 45, 90, which when I do my ratios, we're going to have ratio values of 1, 1, and then root 2. So I know my x value based on the given information is going to be 12. So when I divide in, so 12 divided by 1, which is going to give you just 12, and then I'm going to push out towards the hypotenuse. So that's going to give me a hypotenuse value of 12 root 2 here. Let's actually use a color you can see. Okay, and now we're finished with this triangle over here on the left side. Now we're going to move over to the triangle over here on the right side. Now notice how we gave you those hash marks. That tells you this is an isosceles triangle, which also tells you it has to be 45, 45, 90. So based on the ratios, I know I'm going to have ratios of 1, 1, and then root 2. So I'm going to do another round of DIMO. So I'm going to take this 12 root 2, and I'm going to push in, which means I need to divide in. So 12 root 2 divided by 1 is going to give me 12 root 2. And then I need to multiply out going up towards my y value. So I'm going to have 12 root 2 times 2, or times root 2, sorry, which is going to be 12 times 2, which is going to give you 24. So same idea over here. So on 32, so given that we have a d value, which is your diagonal of 2 root 10, we want to find out what the x value is. So I know this is going to be 2 root 10. So we're dealing with a square here, which means that these angles that are cut are going to be 45, 45, and 90. So based on this, my ratio on the hypotenuse is root 2, and then my two leg lengths are going to be 1. So I'm going to divide by going in. So 2 root 10 divided by root 2 is going to give you 2 root 5. So then when I multiply out, that's going to give me this side length of 2 root 5. And now I want to look at the ratio of this other triangle. So we have a 30, 60, 90. So 30, 60, and then 90. So across from the 30 is going to be 1. And then I don't need the ratio across from the 60. It's root 3. We're looking for the x value, which means I need the ratio of 2. So once again, I'm going to divide in. So 2 root 5 divided by 1 is going to give me 2 root 5. and then I'm going to multiply out. So 2 root 5 times 2, which is going to give me 4 root 5. So these are just giant games of DIMO. So 33 is very similar, but I do want to jump over to number 34. This one's a really good one. So with 34 here, so we want to find the values of B and C, given that A is 10 root 3. So if you'll see these hash marks here and here, this is going to be indicative of parallel lines. Hopefully you remember those from your geometry days. So what's going to happen is if I have parallel lines and I have a line cut by a transversal, parallel lines cut by a transversal, there we go. Then if I have, let's actually extend this a little bit, see if you can get a better picture. There, I want to make it so you can see it, but not too jarring, not too obvious. So I have my parallel line, right here, and then cut by this transversal. So if I have the 30 degrees right here, what that tells me is I'm going to use alternate interior angles, and then that's going to tell me that this angle up here is also 30 degrees. So if that's 30 degrees, that means this angle over here on the far right is 60. Now I can fill in my trig ratios. So, or not trig ratios, sorry, special right triangle ratios. So across from 30 would be 1, across from 60 is going to be root 3, and across from the hypotenuse, which is 90, is going to be 2. So when I divide in, so 10 root 3 divided by 2 is going to give me 5 root 3. And then I want to be able to find my B value and my C value, so I'm going to multiply out going towards the hypotenuse of the other triangle. So multiply out, so 5 root 3 times 3 is going to be 5 root 3 times root 3, which is 5 times 3, which is going to be 15. So now I want to do the ratios of my other triangle down here. So if this is 30 down here, that means this has to be 60. So my ratios are going to be 1, root 3, and then 2. So I'm ready to divide going in. So I'm going to have 15 divided by 2, which is going to be just 15 halves. Leave it as a fraction. And then I'm going to multiply out. So going towards B, multiply 15 halves times 1. So that's just 15 halves. And then going out, multiply out towards C is going to be 15 root 3 divided by 2. So B is going to be 15 halves. And then C is going to be 15 root 3 divided by 2. So that's another good one. All right, and then we have a couple word problems down here. So if the diagonal of a square is 8 root 3 centimeters, what's the perimeter and the area of the square? So I'm going to draw a fancy little diagram. It's not going to be to scale by any means. Okay, so we know that the diagonal is going to be 8 root 3. And of a square, we know that we have 4 right angles. So if those are cut by the diagonal, that means this is going to be 45, 45, and 90. So we are dealing with a special right here. So what I'm actually going to do is I just want to take that triangle. That's not even close. I'm going to take this triangle and I'm going to just look at the triangle. So that means I'm going to look at hypotenuse value of 8 root 3. And then I want to find my leg lengths, given that this is a 45, 45, 90 triangle. So once again, I'm going to do DIMO. So my ratio values of a 45 are going to be 1, 1, and then root 2. So I'm going to do DIMO, I'm going to divide going in. So 8 root 3 divided, 8 root 3 divided by 2. Or root 2, rather. And I'm going to rationalize, so multiply by root 2 over root 2. So this is going to give me 8 root 6 divided by 2, which is going to simplify to 4 root 6. So I know we're going to have 4 root 6 on the inside. It's getting a little muddy, sorry y'all. And then I'm going to push out, which means if you multiply 4 root 6 times 1, we get 4 root 6 for both of your side lengths. So now that I know that the side lengths of my square are going to be 4 root 6 on all sides, now I need to find the perimeter in the area. So the perimeter of a square, it's going to be adding up all the sides, or I can just do 4 times the leg length, which is 4 times 4 root 6, which in this case is going to be 16 root 6. Okay, and then this is centimeters. Make sure I include my units. And then my area, in this case, is going to be your side length squared. So 4 root 6 all squared, which is going to be 4 squared times the square root of 6 squared, which is 16 times 6, which in this case, I believe, if I do my mental math right, it's 96. That'd be square centimeters. Ta-da! All right, and then you want to find the altitude of an equilateral triangle that has a side length of 14. Now, when I say altitude, once again, kind of a throwback to your geometry days. So the altitude is looking at the height. So if I look at an equilateral triangle, we're going to pretend that this is equilateral. So equilateral would insinuate that all of these angles are going to be 60 degrees. Now, I want to find the altitude, which is a fancy way of saying the height. So from the top vertex going down, it's going to be perpendicular. It's going to be a perpendicular bisector, more specifically. So if each leg length is 14, and I have a perpendicular bisector on the other side for this altitude, that means these lengths will be 7 and 7. So this will also serve as an angle bisector, which means this will be 30 degrees. And if I want to find the altitude, I want to find the height. So I'm looking at just this triangle right here, or the other side, depending on how you draw it. So I'm going to draw just that right side. So we have 7, 14. We want to find the height. We know this is 30, 60, and then this is 90. Technically, you could do Pythagorean theorem, but what's the fun in that? So when I do special rights, I know my ratios are going to be 1, root 3, and 2. So I'm going to divide going in. So 14 divided by 2 is going to be 7. And then we're going to multiply out. So 7 times root 3, which is going to give you a height of 7 root 3. And what are my units? 7 root 3 feet. Ta-da!